All right. Let's see. We got sort matrix by diagonals. Medium. You're given a square matrix n by n of integers called grid. Return the matrix such that the diagonals in the bottom left triangle, including the middle diagonal, are sorted in non-increasing order. Okay. So it's almost like decreasing, but it could be the same consecutively. The diagonals in the top right triangle are sorted in non-decreasing order. The diagonals in the bottom left, diagonals in the top right triangles are also okay. So, and I guess you don't sort the middle, including the okay. The middle is included in the bottom left triangle. So the bottom left is in non-increasing order, the top right is in non-decreasing order. So this one's decreasing, this one's increasing. So decreasing here should be 861, 954. Increasing here is 273. So increasing 0, 2, 1. Okay. Decreasing 2, 0, 2, 0. Okay. So you want to sort. I wonder if they want you to do anything special here, because otherwise you just create other arrays. I think you create arrays. How big is n? N is 1 to 10. So it's a 100 element matrix at most. Matrix element. I mean, I guess what would I logically do here? I'd just go through each diagonal, make it into its own array, sort the array, and then repopulate that in the matrix. I mean, I guess I think that's the most straightforward. I don't see any optimizations there. I could use a heap, maybe. Okay. Let's go ahead and iterate over the diagonals. So let's deal with the bottom left triangle. This is sort decreasing value sort values and decreasing non-increasing, but it's pretty much decreasing order. So let's say n is the length of the matrix, which is number of rows, which is number of columns. And then I'm going to go to the bottom leftmost one, because I know that this one is single element. Actually, I might go for the second one, since I don't really need to sort this corner. So what would that be for? I guess it'd be row in range. Row in range n minus 1. Let's say this is n is 3. This is row 2, 1, 0. So no, n is 3. This is row 0, 1, 2. Actually, I want to start with row 1. So I think maybe n minus 2. And then just have a certain offset within that row. actually, this is probably not the structure I want. I'll use for, let's say, offset k in range from 1 to so this is n minus 2 . I want to treat this as 0, 1, 2. So 1 to n. Okay. And k would be, I want to have tree k is almost the length of the array as well. The length of the number of elements within the diagonal. So maybe I should have k equals 2, go to n plus 1. Here's n is 3. This is going to be 2, it's going to be 3. The row value is going to be the row value is initially n minus k. 3 minus 2, this is row 1. Okay. And then for the number of elements, that is let's see, use I. Let's use, I really don't want to use an I as any sort of variable. Since this is a diagonal index, I'll use D, I guess. D in range k. So I want to construct a diagonal array to sort. So diagonal, append the row or the grid at the spot of row minus k, n minus k, or the row is the n minus k. And the column is going to be k. No, column. So initially this is going to be, the column should be what? If k starts at 2 and then goes to 3, so I think the column is going to be k minus 2. So if k is 0, or k is 2, it's going to be n minus 2 is this spot as the row, 2 minus 2 is the column, so it's 0. And then as k increases, the row increases by 1, the column increases by 1. Okay, I think that's right. And then I'm going to do diagonal, sort the diagonal in reverse. And then repopulate it within the matrix. Diagonal or grid at n minus k, k minus 2 is equal to diagonal at d. Oh, and k is going to be, this is incorrect, huh? K is initially correct at 2. No, this n minus k plus d. There we go. N minus k plus d, k minus 2 plus d is equal to the diagonal d. Alright, I think that is correct for the bottom left triangle. I'm going to print that out, see if it works. diagonal append grid n minus k out of range. K is 2. Oh, what happens if it's n minus n plus 1? N is 3. 3 minus 4. That's not right. 2. K goes from 2. N is 3. I want K to be 3 here. But then that means that it'd be 3 minus 3 is 0. Actually, that's right. Huh. Okay, let's go ahead and print. What's going on as the indices 2, 3, 2, 2, 2, 2, 3, 1, 0, 2, 1. 1, 0 is first row, 0 column, second row, first column. That's right. 0. This should be 0, 0, I think. Yeah, it should have been 0, 0. Alright, this is wrong. K minus 2 plus D. Is it? Actually, that should be just D, I think. Whoops. Always starts at column 0. Alright, so the diagonal for the main diagonal should be 8, 6, 8, 6, 1. And then the second diagonal is 6, 6, 5. 8, 6, 1 should be 9, 5. 9 should be the first element of the second row. Second element of the third row. And then lastly 4. Okay, I think that's right. And then the other way is going to be for here. This is going to be top right triangle. This is going to sort values in increasing order. Same setup here for K in range 2. I think this goes to N because I don't want to go to the main diagonal. So 2, and that's it. Diagonal is going to be an empty array for D in range K. I'm going to have diagonal append grid N. So it's the column. The row is always going to start 0 going upwards. The column is going to be N minus K minus D. No, N minus K plus D. And then diagonal.sort. And for a D in range K, grid at D, N minus K plus D is equal to diagonal D. And then I think I can just return the grid. Return the grid. Return the matrix. Okay, yeah. Okay. don't think I have any more prints. Okay. It's pretty simple, I guess. Okay, so pretty much just need to iterate over. Okay, yeah. So summary for this one would be iterate in general. Treat each diagonal separately, or let's say process each diagonal separately, where processing will include transfer elements or values in diagonal to a temporary array. I call this the diagonal array. Sort either descending or ascending, and then transfer values from temp array back to grid, and then since the bottom left triangle are all sorted, are all are similar, can use a nested for loop that will iterate over those diagonals. So the first loop would, in theory, go over the bottom leftmost, like one element diagonal, and then the next loop will go over 2, and then 3, and then 4, and then 5, and 6, all the way to the main diagonal. And that's this thing right here. Here I start with 2 because I don't really need to sort a one element diagonal, but k is the length of the diagonal. In above, k is the length of the diagonal to be sorted, and which can also be used to identify the offset for either row or column of initial element of diagonal. Other elements in diagonal will be plus d away, where d is some incrementing integer. So if this is the first element, then +1 + 1 is going to be this element. If this is the first element diagonal, then +1 + 1 is this, +2 + 2 is this. If you're dealing with these diagonals, if this is first element, again, this is going to be something where the row is always 0, but the column is n minus k approximately. That'll be the position of the first element, and then +1 + 1 from that is going to be this position, +2 + 2 is this position. And then again, within the inner loop of that nested for loop, we'll iterate over the possible +d offsets to to get the values from grid to be added to the temp array. Sort the temp array appropriately, then transfer back using a corresponding nested for loop. Okay. Time flex loop is going to be O of n squared, where n is the length of the side, or is the length of side of square matrix. This can be understood by noting that all elements of matrix are gathered or processed once, or technically twice. To be added when added to temp array and moved back over and transferred back over after sorting. Like there's no duplication of processing. And then space selected is going to be O of n for the temp array that is sorted. The temp array can be at most n elements size of longest diagonal. And if you have a 3 by 3, your longest diagonal is